Alright, here's another proof. First, let's go up to this guy. It says a quadrilateral has two sides that are 3 centimeters long and two sides that are 5 centimeters long. And a student says that it must be a parallelogram. Well, we're going to disagree. Because it's only a parallelogram if the opposite sides are congruent. You could actually make a kite out of it, right? If you position those sides so that the consecutive sides were congruent instead of the opposite sides. So just one of those instances. That's a good thought right there. I'm going to come down and talk about this. You can use a relationship between angles to prove a quadrilateral. Remember, we just proved that 4 sides congruent makes a quadrilateral, or opposite sides congruent. If both pairs of opposite angles are congruent, then the quadrilateral is a parallel angle. So let's try that. So they're going to start by giving us that A and C are congruent, and B and D are congruent, and then we're going to prove it's a quadrilateral. I'm sorry, a parallelogram. So we know that all 4 sides together are 360 by the polygon thumb theorem. That's n minus 2 times 180, right? From the given information, angle A is congruent to angle C, angle B is congruent to angle D, which we've already marked up here. All right. By substitution, right? Instead of saying A plus D plus A plus by substitution, instead of A plus B plus C plus D, right, instead of saying this, we're going to take out the C and plug in an A, right? And then we're going to take out that D up there, or that B right there, and plug in a D. So we substituted, in this case, A for C, and we've D for B, all right? So now that we know that those 4 angles are still congruent, right, we can say 2 angle A's plus 2 angle D's are equal to 360. And if we divide both sides by 2, that means this side and this side. That would say angle A plus angle D is equal to 180. Therefore, A and D are supplementary. All right? A and D have to be supplementary because they add up to 180. And this is by the converse of the alternate near interior angle theorem. All right? The similar argument shows that AD is congruent to BC, is a parallel line. Is a parallelogram by definition of a parallelogram. Let me actually finish that. So there it is. We've taken it and we've proved it. Anyway, what property or theorem justifies both sides of the equation by 2 in the improved? Well, so hey, why can we divide both sides by 2 up here to get this? And honestly, that's the division property of equality. Now, I prefer by far, myself anyway, the 2-column proof. But if you look at this, we really only have one more proof to go, one more page, and I will be right back with you.